Oh, hello. This next part looks a little dicey. Check this out. Let f of x equal p of x over q of x. They don't have any common factors. This is going to tell us all about the asymptotes. All right, check out these sweet asymptotes right here. We got vertical asymptotes. We got horizontal asymptotes. All kinds of asymptotes. If the degrees in the numerator are higher than the degrees in the denominator, then there's going to be no horizontal asymptote. So if the degrees are higher on top than they were on the bottom, there's no horizontal asymptote, which the last couple examples we did, that was the case. If the degrees are larger in the denominator, the horizontal asymptote will be right at y equals 0. Right? So if the degrees are larger on the bottom, there's going to be a horizontal asymptote at y equals 0. And if the degrees in the numerator and the denominator are the same, then the horizontal asymptote will be the leading coefficient of the numerator over the leading coefficient of the denominator. And you'll see one of each example in the ones that we're about to do. We're about to do 3. So, numero uno. Identify the zeros and asymptotes of each function, then graph. We're just going to use our graphs from Desmos because they're so sweet that they just graph them for us when we type it in there. That's so nice of them. So we got to factor this first. We're looking for factors of -6, has to be one positive, one negative, that add up to +1. So they're going to be one apart from each other, essentially. So you got 1 and 6. They're not one apart, though. Or 2 and 3. What? So it's going to factor to x plus 3 times x minus 2 over x. Now let's talk about our zeros. Remember, the zeros mess with the numerator. So it says x plus 3. So our zeros will be -3 and it says x minus 2. So it will also be at 2, okay? Now, talking about the asymptotes, the degrees were larger on top. It was x to the second degree over x to the first degree. And when that happens, there is no horizontal asymptote. So the vertical asymptote can be derived from the denominator, right? And it's x minus 0. So the vertical asymptote is at x equals 0. Again, there is no horizontal asymptote. So let's check our graph. Let's see if our information matches up with the graph. So we have zeros at -3, +2. We have a vertical asymptote right at 0. Never touches that line. And we don't have a horizontal asymptote here. There's no flat line where these things curve away from. Let's try another one. F of x equals x minus 1 over x squared. I'm going to have to sneeze here in a minute. But if you look, we have the first degree in the numerator. We have the second degree in the denominator. Now, when that happens, we are going to have a horizontal asymptote on this one, as well as the vertical asymptote. So our zeros, you look at the numerator, and it says x minus 1, so we're going to have a 0 at 1. And then let's talk about the vertical asymptote, which deals with the denominator, right? It's just x squared. There's no plus, there's no minus. So our vertical asymptote will be right at x equals 0. And then remember we said the denominator had the higher degree, so when that happens, our horizontal asymptote will be right at y equals 0. So let's check our graph. Whoa! We've got a vertical asymptote right at 0. We've got a horizontal asymptote at 0. And we got a 0 at 1. Huh.